Good evening, everyone. I'm James.
In today's industry, the demand for non-ferrous metals are becoming more and more popular. Millions and tons of non-ferrous metals, such as aluminium, copper, lead, and zinc, are recycled annually for use amongst smelters, refiners, ingot makers, and other manufacturers. In particular, aluminium is the most abundant material in the Earth's crust, and it is actually also the most recycled metal other than zinc and also paper. And why is it so widely recycled, aluminium? The main reason is that it is actually very economically viable, and it has a lot of simple uses such as packaging. Further non-ferrous materials such as lead, zinc are also recycled on a daily basis because it is a cheaper option than mining, which confirms that secondary materials are essential for the survival of many industries. The logic of recycling these materials has been made more appealing as sellers can actually benefit from cash rewards, and it is a win-win situation where you get to protect the environment and also gain benefits for the sellers. Many recycling companies these days actually face the problem of separating ferrous metals and also non-ferrous metals from construction or demolition waste or even domestic waste. So that is why a non-ferrous metal separator is invented. And the non-ferrous metal separator is also known as the eddy current separator. So now let us watch an experiment about eddy current.
Okay, first we need to set up our experiment. Right, so here we have 12 really strong magnets. So we'll group it into groups of 3. Just like this. So it will form a more stronger magnetic field than we use one magnet alone. Then take the magnets to the circumference of the Pringles lid to make sure they are equally spaced. Then poke a hole using needle in this center of the lid when they are equally spaced.
After attaching the magnets to the wheel, we then attach the wheel of magnets to the motor. And then connect the motor to the battery using crocodile clips. And then turn on the motor by just doing this because we didn't have a switch.
Alright, so we are going to use this plastic container to hold the material to prevent them running out.
First, we're going to try it with the plastic cap. Something like that. doesn't move because plastic is a non-metal, and doesn't have any ions, free moving ions, so it doesn't get affected by the magnetic field. We're going to try it now with the aluminum, which is a non-ferrous metal. As you can see, the aluminum moves because the constantly changing magnetic field from the spinning magnets produces a repulsive force with the aluminum coil, which is a conductor. Now we're going to try it with ferrous material, which is iron. We're going to cover the plastic container so to prevent it from flying out. As you can see, the iron attracts to the magnets. So in the non-ferrous metal separator, the iron will attract to the changing magnetic field, and then that will separate it from the non-ferrous and the non-metal.
I'm going to be doing the explanation for Faraday's law, Lenz's law, and how it relates to the non-ferrous metal separator. First is Faraday's law, which originated from Michael Faraday. Faraday's law states that a change in magnetic flux experienced by a conductor will induce an electromotive force and a current in that conductor. Like when a magnetic field is cut with a conductor, a current will be induced in that conductor. Example, here we have a solenoid coil connected to a galvanometer, and once we introduce a magnetic field into the solenoid coil, the magnetic field lines are cut by the wires in the solenoid coil, and the galvanometer indicates that there is a current induced that is moving clockwise. Next, I'm going to talk about Lenz's law. Lenz's law is introduced by a man with the last name Lenz. Lenz's law states that an induced EMF electromotive force will give rise to a current whose magnetic field opposes the change in the original magnetic field that caused or induced the current. To demonstrate, we have a solenoid coil again connected to a galvanometer. Then we have a magnet with its north pole facing the solenoid coil. When we move the magnet towards the coil, the magnetic flux in the coil increases, and this causes the induced current in the coil to produce a magnetic field that opposes the change in the magnetic field. When the magnet is not moved and even though the magnetic field lines are still inside the coil, there is no induced EMF produced because there is no change in magnetic flux, and the reading of the galvanometer reads 0. When the magnet is moved away from the solenoid coil, the magnetic flux decreases inside the wire, and the induced EMF will produce a magnetic field that is the same as the original magnetic field, which is the magnet. Now let's try it with the south pole facing the magnet. When the magnet is moved towards the coil, the magnetic flux increases, and an induced EMF in the coil produces a magnetic field that opposes the change in magnetic flux or the original magnetic field in the magnet, and the galvanometer reading shows that there is current flowing anti-clockwise in the coil. When the magnet isn't moved, the magnetic flux in the wire does not change, so there is no EMF induced in the coil, and the galvanometer reads 0 because there is no current flowing through the coil. And when the magnet is being pulled out, there is a change in magnetic flux in the coil where the magnetic flux decreases, and the induced EMF in the coil produces a magnetic field that is the same as the original magnetic field, which is the magnet's magnetic field, and a current is induced in the coil moving clockwise throughout the coil. In the non-ferrous metal separator, the non-ferrous metal separator consists of a conveyor belt and a wheel of fast rotating magnets. This wheel of magnets rotates really fast to produce a constantly changing magnetic field. When a conductor passes through the changing magnetic field created by the fast rotating magnet that is placed under the conveyor belt, it will change the magnetic flux that will result in eddy current induced in the material itself. Eddy current creates a magnetic field that opposes the original changing field that created it. This opposing force causes the conducting material to be ejected further in the conveyor belt.
Okay guys, so I'm going to talk about non-ferrous metal separator. I'm sure that everyone has a question in their mind. What is non-ferrous metal separator? Non-ferrous metal separator, also known as eddy current separator. The conveyor belt of the separator separates and carries away non-ferrous metal continuously and fully automatically. An important factor for good separation is an even flow of material supplied by a conveyor belt. This results in a good uniform distribution across the belt, so that the material arrives as a monolayer. This means that the supplied layer thickness is about as thick as the largest piece, and thus that there are no pieces lying one on top of another. This is especially important with smaller fraction sizes. The separators are built so they can remain operational day and night in even the most demanding application. The main purpose of the eddy current separator are sorting the mixture of varying types of scrap metals and separating the precious metal like gold, silver. The advantages of the non-ferrous metal separator are it can able to recycle materials and particles from sorting them out into ferrous and non-ferrous metal in order to manage waste with more efficiently in the industry. The disadvantage of this metal separator is heat energy is created when the cycling of eddy current causes loss of energy due to friction in the magnetic circuit, especially when the core is saturated. So, what is non-ferrous metal and ferrous metal? Non-ferrous metal is a metal that do not contain iron. They are generally more costly than ferrous metal. Non-ferrous metal are used because of the desirable properties such as low weight, non-magnetic properties, or even more resistance to corrosion than ferrous metal. The example of ferrous metal is stainless steel, iron. Non-ferrous metal examples such as copper, aluminium.
Hi everyone, so how does the non-ferrous metal separator actually work? Before I begin, Ashley has already gone through the concepts and laws involved in its working principle, and Elvin has actually explained what is a non-ferrous metal separator. So now I'm going to proceed with the working principle of the non-ferrous metal separator. So first and foremost, the non-ferrous metal separator actually works in two different parts. It can be divided into the ferrous metals separation, followed by the separation of non-ferrous metals and dry recyclables. So before we focus on non-ferrous metal separation, we're going to look at the separation of ferrous metals. In the working principle of ferrous metal separation, a magnetic drum is used. The eddy current will generate a magnetic field which will counteract the magnetic field from the magnetic rotor. This will cause ferrous metals to stick to the belt for a short amount of time as it revolves and then be discharged behind normal trajectory. Non-ferrous metals and non-metals, for example glass and plastic, will not be affected and will free fall forward following the normal trajectory. The drum acts as a head pulley of the conveyor, carrying the remaining products to be separated. In this case, it is any non-ferrous metals and non-metals that are carried by the conveyor over the drum. And that's basically it for ferrous metal separation. Secondly, we're going to look at the non-ferrous metal separation. A high-speed magnetic rotor is fitted within a non-metallic drum. The rotor travels much faster than the metallic drum, and the rotation speed of the magnets generates an induced induction field, creating a rapidly changing magnetic field. If a metallic object is placed in an alternating magnetic field that is created by the magnetic rotor, according to Faraday's law, the metallic object will temporarily magnetized and current is generated inside the metallic object. The current generated inside the metallic object is called eddy current. According to Lenz's law, eddy current will also be created in the magnetic field to oppose the change in magnetic field, which means eddy current will react back on the source of the magnetic field. This will cause an eddy current to be induced inside the non-ferrous metal. These opposing fields results in a combined driving and repelling force, which literally ejects the conducting particle from the product stream, thus repelling the non-ferrous metals over the splitter plate. The remaining materials such as plastics, glass, and other non-metals will simply free fall over the rotor under the influence of gravity and momentum. Therefore, non-ferrous metals, ferrous metals, and the non-metallic materials will all be separated.
I'm Emily, and now I'm going to talk about the modification to improve the separator. The first modification we can use is the rotating crusher. The rotating crusher is used to crush the bigger pieces of the material to the small pieces of the material. As you can see at the beginning, the bigger pieces of the material at the top become smaller and smaller, and at the end, the smaller pieces are easier to be separated and increase the efficiency. And the next modification we can use is the weight sensor. This sensor is used to detect the weight of the material, and then the speed of the motor will be adjusted automatically according to the weight by increasing and decreasing the repulsive force. It means when the scrap is very heavy, the motor will go faster, and if the scrap is very light or small, it will go slower. This is to make sure the different weight of the metal will not be propelled too far away or too little. And we can also install the cooling system in the separator. When the eddy current repel the particles, they tend to heat up and change the kinetic energy into the heat energy onto the particle. We can add the fan or pour a cooling inner liquid such as water into the separator so that the separator could be cooled down.
So basically that's it from us. I hope you learned a thing or two about the non-ferrous metal separator. If you have any questions, feel free to ask us, or more preferably Mr. Tan Pei Yan. And that's it from us. Thank you so much.